I want you to try and imagine the sheer, physical scale of 480,000 brand new cars.
Oh, it's massive.
Right. I mean, we are talking about giant cargo ships crossing oceans, freight trains loaded bumper to bumper, just metal rolling into driveways all over the planet in a single quarter. It is a completely staggering logistical achievement.
Yeah, and Tesla just reported those record-breaking delivery numbers.
Exactly, which resulted in a massive revenue beat right around $28.24 billion. And if you just look at those top-line numbers, you'd naturally assume, well, the company's bank accounts must just be overflowing with cash.
You would think so, yeah.
Yeah.
But when you actually open up the Q2 2026 financial deck, the reality is this massive corporate paradox.
Which is wild.
It is. Despite moving more metal than ever before, their operating margins just plunged. And even more shocking to a casual observer, their free cash flow didn't just take a dip. It went negative by over $1 billion.
$1 billion negative. So today, we are doing a deep dive into the raw earnings call transcript, the financial decks, and some of the surrounding market reports to figure out how a company can sell a record number of cars, completely dominate the globe with the Model Y, and still manage to lose cash. How does that mechanism actually work?
It's a really complex mechanism to unpack.
It really is. And before we break down these market mechanics, I just want to quickly remind you, our listener. Okay, let's unpack this financial paradox. Seeing a headline about negative free cash flow, that usually triggers panic, right? It sounds like a company's bleeding out. What is the actual math happening here?
Well, to really understand the math, we have to isolate what free cash flow actually measures.
Okay.
It's basically the cash a company generates from its daily operations minus its capital expenditures.
Right. And capital expenditures, that's CapEx, right?
Exactly, CapEx. Those are the massive investments in physical infrastructure. So things like new gigafactories, expanding production lines, or, in this specific case, building colossal computer data centers.
Okay, so it kind of reminds me of a bakery. So if I'm running a bakery, my free cash flow going negative doesn't necessarily mean my cookies aren't selling, right?
Right.
It could just mean I took all my cookie profits and spent them on buying 5 brand new, crazy expensive ovens for the future.
That is actually a highly accurate parallel. It's very much like Amazon in the early 2000s, too.
Oh, yeah, when they were building AWS.
Exactly. Back then, they were an e-commerce company operating on razor-thin retail margins, but they were taking all of their cash and spending billions to build giant server farms.
And Wall Street hated it at the time.
Oh, Wall Street was incredibly frustrated because the cash flow looked terrible. But Amazon was essentially sacrificing short-term cash to build out a totally new, highly profitable digital infrastructure. And that's what we're seeing here. Tesla is choosing to run its cash register down to zero and even into the negative to buy the shiny new ovens, so to speak, for its next chapter.
Right. So the negative cash flow isn't a sign of operational failure. It's a deliberate capital allocation strategy.
Exactly. Very deliberate.
But, before we get to what they are actually building with all those billions, we really have to look at the bakery itself, the core automotive business that is actually funding this entire transition. Because if the core business falters, the whole futuristic vision sort of collapses, doesn't it?
It does. And looking at the Q2 automotive numbers, you can see a business that's fighting some very heavy gravity right now.
Yeah, let's look at the top line first.
Well, top line was actually strong. Automotive revenue was up 23% to $20.52 billion. And, the Model Y is still holding its crown as the best-selling car in the world.
Which is huge.
It is. Dominating across South Korea, Australia, Taiwan, Europe. They produced over 450,000 vehicles. So the volume is undeniably there.
The volume is there, yeah, but the profit left over per car is shrinking.
Shrinking rapidly, yes.
Because overall, gross margins dropped to 16.8%, which actually missed Wall Street's 19.4% expectation. And then the operating margin, which is what accounts for all their overhead and operating expenses, that fell off a cliff to 1.4%.
Down from 4.1% the year ago.
Right, and earnings per share came in at an adjusted 33 cents, way below the 51-cent estimate. So why is the margin getting squeezed so severely when volume is literally at an all-time high.
It really comes down to a collision of intense external pressures and the actual financial mechanics of selling cars in a difficult macroeconomic environment.
Okay, break that down for me. External pressures first.
First, the competitive landscape has completely shifted. I mean, Tesla is no longer just competing with legacy automakers who are trying to figure out batteries.
Right, the landscape is totally different now.
Exactly. They are fighting a fierce price war with these fast-moving, highly capitalized Chinese automakers. We're talking about BYD, NIO, Xiaomi.
Yeah, Xiaomi makes phones, and now they make cars.
Right. And these companies are rapidly expanding globally, offering very high-tech EVs at significantly lower price points.
So they're essentially fighting tech companies that build cars, rather than, traditional car companies trying to bolt tech onto a chassis.
That's a great way to put it. And the sources also highlight some major macroeconomic and geopolitical crosscurrents that are affecting demand.
Yeah, the global picture is highly fragmented right now. And just to be super clear for you listening, we are strictly analyzing the market impact as reported in these sources. We're not taking any political sides or making judgments here, just reporting what the data shows.
Absolutely. So on one hand, you have the U.S. and Iran conflict, which has driven up global gas prices.
Which is actually a tailwind for them, right?
Yeah, exactly. It acts as a massive tailwind for EV sales in places like Europe, where consumers are highly, highly sensitive to fuel costs. But then, simultaneously, in the U.S. domestic market, the sources note that politically charged rhetoric and public associations with the Trump administration have actually caused some prospective buyers to boycott the brand.
Oh, wow. So that creates a localized headwind.
Right. So demand is literally being pushed and pulled by global events that are completely outside of Tesla's control.
But there is also a very specific financial mechanism mentioned in the earnings call that is directly eating into these margins, right? Subvention. I had to look this up. How does subvention actually work behind the scenes?
Yeah, subvention is a big one. It's essentially an automaker subsidizing the cost of a customer's auto loan.
Okay.
We are currently in a high interest rate environment, as everyone knows. If a customer goes to a bank for a car loan right now, the high interest rate makes that monthly payment just unaffordable for a lot of people.
Right. The math doesn't work for the average buyer.
Exactly. So to keep the volume of cars moving off the lot, Tesla steps in and pays the financial institution a lump sum of money up front to basically buy down that interest rate for the customer.
Wait, so they are essentially taking money out of their own pockets and handing it to the banks just to get the customer's monthly payment down to an acceptable number?
Yes. And structurally, that upfront payment is recognized on Tesla's books as a reduction in the vehicle's revenue.
Oh, I see.
So it artificially lowers the average selling price, or ASP, of the car. Every single time they use subvention to move a vehicle, it takes a direct bite out of their gross margin.
Man. So they are running on a very steep financial treadmill right now. They have to sell more and more physical cars, battling global competitors and subsidizing high interest rates just to generate a shrinking pool of cash.
Exactly, which completely explains why they are pivoting so aggressively.
Right. If the automotive treadmill is getting this hard to run on, you have to find a new treadmill.
You do.
And that negative $1 billion in free cash flow, that is their ticket out of the traditional auto business and into the artificial intelligence arms race.
The scale of this pivot is just staggering. I mean, Tesla's capital expenditures soared 142% to $5.79 billion in a single quarter.
That's insane for one quarter.
It is. And they are projecting to spend over $25 billion this year alone. Elon Musk actually described it on the call as the fastest industrial scale-up since World War II in America.
Which is a bold claim, but I think we should contextualize this because they aren't the only ones spending at this clip.
No, not at all.
The CNBC source draws a direct comparison to Alphabet, Google parent company. The entire mega-cap tech sector is basically lighting their current cash flow on fire to build AI infrastructure.
Yeah, Alphabet's free cash flow sank to negative $5.9 billion because they are projecting up to $205 billion in capex.
$205 billion. That makes $25 billion look small.
Right. But Tesla is participating in that exact same infrastructure race. They are building colossal computing data centers like the new Cortex clusters in Texas.
Right, for AI training.
Exactly. And they aren't just buying off-the-shelf hardware anymore either. They are pouring billions into designing their own custom silicon, specifically the new AI5 and AI6 compute chips.
And those are heavily optimized for training visual artificial intelligence, right?
Exactly.
Okay, so this massive supercomputer infrastructure is entirely dedicated to solving basically two problems: robotaxis and humanoid robots. Let's start with the cars.
Sure.
Because the whole strategy requires customers to actually adopt the self-driving software. The metric the sources focus on here is the attach rate. What exactly is that?
The attach rate measures the percentage of people who buy a Tesla vehicle and then actually choose to pay extra for the full self-driving or FSD software subscription.
Got it. And how are they doing on that front?
Really well. This quarter in North America, that attach rate hit a record 55%.
Wait, really? More than half?
More than half of all new buyers are opting into the software. It pushed their active subscriber base to 1.48 million globally.
Wow. That is a massive pool of revenue that has absolutely nothing to do with bending metal.
Yeah, pure software revenue.
And the software driving this, FSD version 15, is logging some pretty wild metrics, right? Ashok Elaswamy, the VP of Autopilot, reported they have logged 380,000 unsupervised miles in complex urban environments like Austin and Miami.
Yeah, and the mechanism behind how they are achieving this is really what separates them from the rest of the industry.
How so?
Well, competitors like Waymo, they rely heavily on LiDAR.
Oh, right, those spinning laser things on the roof.
Exactly, those expensive laser sensors that bounce light around to create a perfect predefined 3D map of the city. But Tesla is betting entirely on a camera-only vision system.
So no LiDAR at all?
No LiDAR. The car relies on standard cameras feeding real-time video into a neural net, basically trying to mimic how human eyes and brains process the road.
That sounds infinitely harder to train.
It is infinitely harder to train, but it is vastly cheaper to scale, because you don't need a $50,000 laser array on every single vehicle you sell.
That makes sense.
Yeah.
And their safety claims on the call were pretty bold. They stated there were 0 notable incidents over those 380,000 unsupervised miles. And they said any minor collisions were just caused by other human drivers hitting the stationary robotaxis.
Yeah, they are so confident in this camera-only vision that they have already started production on the Cybercab at Gigafactory, Texas.
The Cybercab, right. That's the custom-built 2-seater autonomous EV, right? With literally no steering wheel and no pedals. Just a cabin and a giant screen.
That's the one. They are actually already running a fleet of them on the Texas campus, allowing employees to take completely unsupervised rides, so the engineering confidence is clearly there.
See, I have to push back heavily on this strategy, though.
Okay, why is that?
Well, building the data centers, designing the AI-5 chips, and engineering a completely new chassis is one thing. But they are banking this entire multi-billion-dollar pivot on regulatory approval.
That is the big catch.
Right. The United States does not have a single federal framework for autonomous vehicles. It is a patchwork of 50 different state regulators. Designing a car without a steering wheel before it is actually legal to sell everywhere seems like an unacceptable level of capital risk. What if California or New York simply says no?
You are identifying the central vulnerability of their entire valuation right there. And to be fair, the executive team did address this regulatory friction on the call.
What did they say?
They believe they have a strong working relationship with federal agencies like NHTSA, but they absolutely acknowledge the state-by-state rollout is going to be grueling.
Grueling's a good word for it.
Yeah.
Because math doesn't always win in politics, you know. You can show a regulator that the software is statistically twice as safe as a human driver, but the moment one unsupervised robotaxi hits a pedestrian, it'll be the lead story on every global news network. The political blowback would be instant.
And Elon Musk explicitly acknowledged that exact reality on the call. He noted that a single severe injury would create a global media firestorm, and regulators could instantly freeze their operations.
So they know the risk.
Oh, they know. But from their perspective, if they wait for blanket federal legislation to pass before they start building the factories and the cybercabs, they will be 5 years too late to capture the market.
Oh, I see. So they are essentially forced to build the parachute while they are already falling.
That's exactly what they're doing.
It is an incredible high-wire act. But the self-driving cars only represent half of this AI pivot.
Right. The other half is arguably even crazier.
Because if you have spent billions solving the mathematical problem of an AI navigating a complex 3D world on 4 wheels, the next logical step is having it navigate that same 3D world on 2 legs.
Which brings us to the Optimus humanoid robot.
Optimus, yes.
From an engineering standpoint, this is arguably the most difficult manufacturing challenge Tesla has ever attempted.
Why is that?
Well, think about building a car. It's complex, sure, but there is a deeply established global supply chain for it. If you want to manufacture an electric sedan, you can call up Tier 1 suppliers and order windshield glass, brake calipers, side mirrors.
Right, you can just buy the parts. But there is no catalog for humanoid robot parts. You can't just call a supplier and order 10,000 robotic ankles.
Exactly. You cannot outsource a robotic hand that requires human-level tactile dexterity because the supply chain simply does not exist. So Tesla is being forced to vertically integrate.
Meaning they have to build everything themselves?
From scratch. They have to engineer, prototype, and manufacture these entirely new electromechanical actuators. They actually decommissioned the old Model S and X manufacturing lines in the Fremont factory just to clear floor space for the first-generation Optimus production line.
Wow, they killed the S and X lines for this.
Yep, just to make room.
And they are training these robots using something called the Optimus Academy, right?
Yeah, this is fascinating.
Because the robot is built in a human form factor, they're deploying the initial builds into their own factories to basically observe human workers.
Yeah.
And they use reinforcement learning, which is essentially trial and error software that mathematically rewards the robot for completing a task successfully. So it learns by practicing on the factory floor rather than being hard-coded line by line by a programmer.
It's incredible tech. But all of this, the millions of cars constantly uploading video data, the complex reinforcement learning for Optimus, the real-time routing of the cybercabs, it all requires an unfathomable amount of computing power.
Right.
And computing power requires physical electrical power.
Okay. This is where we have to look at the hidden engine of this entire ecosystem, Tesla's energy sector, and how they are utilizing synergies with SpaceX.
Yeah, these pieces are crucial.
Let's look at the energy side first. In the Q2 deck, they reported deploying a record 13.5 gigawatt hours of energy storage, which is a 41% increase sequentially. That's a massive jump.
It is, and a massive driver for that energy storage demand is actually the AI industry itself.
Really? How so?
Well, when a massive cluster of GPUs is training an AI model, it does not draw power smoothly.
Okay.
You've got thousands of processors syncing complex mathematical equations simultaneously. When they execute a calculation, they draw this colossal spike of electricity all at once. Then, when the cycle finishes, the power consumption can plummet by like 70% in just 100 milliseconds.
Oh, wow. A standard municipal power grid cannot handle that kind of violent whipping back and forth. It would cause rolling blackouts everywhere.
Precisely. You need highly advanced power electronics to act as a buffer. So tech companies are buying massive commercial battery installations, specifically Tesla Megapacks, to sit between the grid and their AI server farms.
Oh, I get it. So the batteries absorb the steady power from the grid and then instantly discharge it to handle those massive GPU power spikes, keeping the whole system stable.
Exactly. Tesla is essentially selling the picks and shovels for the AI gold rush.
That's brilliant. They are building their own AI while simultaneously selling the commercial batteries required to power their competitors' AI.
It's a very smart play.
But how does SpaceX fit into this architecture? Because, rockets and robotaxis don't really seem like a natural overlap.
The synergy there really comes down to connectivity and management. Think about a cybercab with no steering wheel. A lost cellular signal is a critical safety failure.
Right. If the vehicle drives into a dead zone, a human can't just take over.
Because there's no wheel.
It would literally just freeze in the middle of an intersection.
Exactly. So to prevent that, they are integrating SpaceX's Starlink satellite internet directly into the Cybercab fleet, ensuring they have high bandwidth connectivity literally anywhere on the globe.
That's wild.
And furthermore, SpaceX's artificial intelligence division, xAI, has developed a model called Grok. And Grok is being positioned to act as the higher level sort of manager or interface for what they are calling digital Optimus.
Okay, when you zoom out and look at all these pieces together, Tesla really ceases to look like a car company.
Wow, entirely.
I mean, they are becoming the power plant with their megapacks. They are the internet provider via Starlink. They are the brain designing their own AI-5 silicon. And they are the physical body with the Optimus robot. It is this entirely enclosed, vertically integrated technology ecosystem.
It is, but as we discussed, building that enclosed ecosystem is currently consuming cash at an unprecedented rate, which brings us full circle to that financial paradox we open with.
Right, the negative free cash flow.
Yeah.
Let's distill all this down for a second. We've covered autonomous miles, global macroeconomics, subvention, reinforcement learning. What are the core takeaways our listeners really need to walk away with today?
I'd say there are three definitive takeaways from this quarter. Number one, Tesla's core automotive business is still an absolute behemoth in terms of physical volume, but it is facing severe margin compression.
Right.
They are caught in a brutal cycle of high interest rates requiring expensive subvention alongside aggressive global competition from Chinese automakers.
So they're selling more cars than ever, but making significantly less profit on each one.
Exactly. Takeaway number 2. Rather than hoarding cash to weather that automotive storm, Tesla is leaning heavily into the risk. They are intentionally driving their free cash flow negative to fund a massive $25 billion plus build-out of AI supercomputers and custom silicon.
Okay. And the final takeaway.
The future valuation of this company is no longer tied to how many hatchbacks they can manufacture. It hinges entirely on their ability to solve the regulatory and engineering hurdles of unsupervised robotaxis, and their ability to scale the Optimus robot without a pre-existing supply chain.
So they are essentially recreating the Amazon AWS playbook, but with physical infrastructure this time.
Precisely.
They have emptied the cash register to buy the most advanced technology in the world, trying to basically will a sci-fi future of robotic assistance and steering wheel-less taxis into existence.
That's the gamble.
It's a huge gamble. But here's a final thought for you, our listener, to sort of mull over on your own. Tesla, Alphabet, and the rest of the mega-cap tech sector are heavily testing the patience of Wall Street right now by burning billions in cash today to build the infrastructure of tomorrow. But what happens if consumer adoption is slow? What if the state-by-state regulatory crawl for autonomous vehicles takes 10 years instead of 2?
Yeah, that's the real risk.
Will the financial markets have the patience to keep funding this cash-burning ecosystem? Or will the capital run out before the future actually arrives?
That is the multi-billion-dollar question that will completely define this investment cycle.
It really is. Well, thank you for joining us on this deep dive into the mechanics of the market. We will see you next time.